Yes, welcome. We are continuing the laws of indices. We are continuing the what? Laws of indices. We've looked at the multiplication law, isn't it? Now we're going to look at the division law. Division law. Division law simply states that if we have a to power x divided by a to power y, can you see that the bases are equal?
Yes.
Their bases are what? A to power x, a to power y. A index x and a index was y. If it is division mark that is separating them, it's similar to saying a, the base, the first index minus what? The second index. Is that clear? So if you have 2 to the power 9 divided by 2 to the power 6, what would be the answer? 2 to the power what? 3. Because it's the same thing as saying 2 to the power 9 minus what? 6, which is 3. Is that clear?
Yes, sir.
And why is it so? Because 2 to the power 9 it simply means 2 into 9, is it not?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the power 6 is 2 into what? 6. 1, 2, 3, 4, 5, 6. Is it not?
Yes.
So if you say 2 cancel 2, 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 2 cancel 2. How many 2 will be remaining?
3.
And this 3, 2 is the same thing as saying 2 to the power what? 3. I see that.
Yes,
so that's why we come about the rule that a to the power x divided by a to the power y is the same thing as saying a to the power x minus what? Y. Then power rule or power law simply states that if we have a to the power x in bracket y, is the same thing as saying a to the power x times y. Is that clear? So if you have 2 to the power 3 in bracket 2, is that clear? Is the same thing as saying, can you see that this is 2 to the power 3 into 2 places, but
yes.
2 to the power 3 times 2 to the power 3. So if you spread it across, you see 2 to the power 3, 1, 2, 3, 2 to the power 3, 1, 2, 3. Is that not clear?
Yes.
Which is the same thing as saying 2 to the power 1, 2, 3, 4, 5, 6, 2 to the power 6. Is it not?
Yes.
So that's why when you say this, it's the same thing as saying 2 to the power 3 times 4, 2. 3 times 2 is what? 6. 2 to the power 6. Is that clear?
Yes, sir.
So let's look at another law. Let's look at another law known as the product power law. Known as the what?
Product power.
That's number what?
4.
Number 4. The product power law. The product power law. What does it state? ABX is the same thing as saying, this will simply say that when you have A, B, all to the power X, is the same thing as saying A to the power X, B to the power X. So example, if we have 3PQ, 3PQ to the power 2, is the same thing as saying 3 to the power 2 times b to the power 2 times what? Q to the power 2. Is that clear? Which will give us 9b 2q2. Is that clear?
Yes.
Write it down. Then number 5 is what we call the zero law. The zero law, which states that anything to the power 0 is the same thing as 1. A to the power 0 is the same thing as what? 1. Is that clear?
Yes.
X to the power 0 is the same thing as what? 1. 1000 to the power 0 is the same thing as what? 1. Any number to the power 0 is equal to 1. 1. Is that clear?
Yes.
Any number to the power 0. Why? Because if we say 2 to the power 3 divided by 2 to the power 3. You know it's the same thing as saying 2 to the power 3 minus 3, but
yes.
Which is the same thing as saying 2 to the power what? 0. But
Yes.
is it not?
Yes.
So how is it 1? 2 to the power 3 is the same thing as saying 2 times 2 times 2, is it not?
Yes.
So divided by another 2 to the power 3, which is 2 times 2 times 2, is it not?
Yes.
2 divided 2, 2 divided 2, 2 divided 2, it will give us equal to 1. So write it down. Product power law and zero law. Have you written it down?
Yes, sir.
Can I go on?
Yes, sir.
Can I clean the board?
Yes, sir.
Now we are going to look at the negative index rule. Negative index rule. That's the next rule. That's rule number what? 6, Mark.
Yes.
The negative index law. It simply states that a to power minus x is simply the same thing as saying 1 over a to power what? X. Can you see that?
Yes.
A to power minus x is the same thing as 1 over a x. Is that clear?
Yes.
So example is when we have 5 to power minus 4 is simply the same thing as 1 all over 5 to power 4. Is that clear?
Yes.
Is that clear?
Yes, sir.
So instead of, if you want to remove this negative sign and a to power minus x, you simply say 1 over a to power what? X. Now we look at rule number 6. These rules you are going to be using them when you start solving indices proper. Is that clear?
Yes, sir.
Roots power. Rule number 7 is known as what? Roots power law. Roots power law. How does it work? A to power 1 over 2 is the same thing as a to power 1 over 2 is the same thing as root of what? A. Instead of saying 1 over 2, you can say root of a. It's the same thing. Is that clear?
Yes, sir.
And a to power 3, a to power 1 over 3 is the same thing as the cube root of a. Cube root of what? A. That's the same thing. Is that clear?
Yes, sir.
A to power 1 over 2 is the same thing as saying root of what? A. It's just like saying 4 to power 1 over 2 is the same thing as what? Is the same thing as what? Root of 4, which is what? 2. What? Then if you say 4 to power 1 over 3 is the same thing as what? The cube root of what? 4. Is that clear?
Yes, sir.
Now we look at another rule. Rule number 8. Rule number what? 8. We call it the what? Fraction. Fractional index. The fraction what? Index. How does this one work? Nth root of a, nth root of a to power m, nth root of a to power m, nth root of a to power m is the same thing as saying a to power what? M over n. Is it similar to the one, is the reverse of what we've just done before, is it not?
Yes, sir.
So in essence, when you say that a to power m over n is the same thing as saying nth root of what? A to power what? M. Similar. Is that clear?
Yes, sir.
So with that, we can solve so many, with these rules, we can solve so many problems in indices. We can do what? Solve so many problems in indices. With these laws, have you written down all the laws?
Yes.
So let's try some problems in indices, some indices expression. Evaluate a to the power 1 over 3. Evaluate 8 to the power 1 over 3. Evaluate 8 to the power 1 over 3. Who can tell me the simplest form of that? Evaluate 8 to the power 1 over 3. 8 to the power 1 over 3 from the rules. What's the rule that we have to use?
Power nodes.
Cube root of what? 8. Is it not?
Yes.
And what is the cube root of 8? What factors that when you bring them together into 3 it will give you 8? 2 back?
Yes.
That's the answer. Because 2 times 2 times 2 is the same thing as what? 8. Is it not?
Yes, sir.
Now if we have 16 over 81 divided by, evaluate B, 16 over 81 all to power 3 over 4. How do we solve this? 16 over 81 all to power 3 over 4. You know that this expression from the last law that we gave is the same thing as what? The fourth root, right?
Yes.
Because 4 is here. Of what? 16 all over what? 81 all to power what? 3. Is it not?
Yes.
Fourth root of what? 16 all over what? 81 all to power 3. It's similar to this expression. 16 over 81 to power 3 over 4 is the same thing as fourth root of 16 all over 81 to power 3. Is it not? Then 16 is the same thing as saying 2 times 2 times 2 times 2. 2 times 2, 4, 4 times 2, 8. 8 times 2 was 16. Then 81 is the same thing as saying what? 3 times 3 times 3 times 3. Is it not? 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. Is that clear? So what do we do to this now? What is the fourth root of 16? Fourth root of 16 is 2. Fourth root of 3 is what? 3. Is it not? All to power, they are normal 3. Is it not? Now 2 to power 3 is what? 8. 3 to power 3 is what? 27. That is the answer. So write it down.